Have you ever looked up at the stars and wondered, how do those giant rockets actually reach space? It seems almost magical, right? But behind every launch is a mix of science, engineering, and a lot of human curiosity. Today, I'm going to break it down for you. From the moment a rocket ignites, to the second it slips into orbit. We'll keep it simple, fast, and straight to the point. So buckle up and let's go on this cosmic ride together. First things first, a rocket isn't like a plane. While planes soar through the sky using wings and engines, rockets are a whole different beast. Planes need air to work, but rockets carry their own oxygen. That's why they can fly where there's no atmosphere at all. This is what lets them escape Earth and travel into the vacuum of space, where there's no air to breathe or burn. So, what's the magic? It's Newton's third law. Every action has an equal and opposite reaction. This law is the secret behind every rocket launch, whether it's a tiny model or a massive space vehicle. When the engines fire, they push hot gases down and the rocket goes up. Just like when you jump off a boat and the boat moves back. The force of the exhaust, shooting downward, pushes the rocket upward with incredible power. At launch, the engines burn a crazy amount of fuel. We're talking about tons and tons of fuel being burned every second, just to fight gravity and get off the ground. The bottom of the rocket, called the first stage, is basically a giant fuel tank with engines. It creates massive thrust, sometimes more than 3.5 million kilograms. That's the kind of power you need to lift something so heavy off the Earth. That's enough to lift a skyscraper. Imagine the force needed to move an entire building straight up into the sky. But here's the smart part. Rockets are built in stages. Each stage has its own engines and fuel, designed to be used up and then dropped away. When the first stage runs out of fuel, it drops off. Why carry extra weight, right? Shedding empty tanks makes the rocket lighter and more efficient as it climbs higher. Then, the next stage fires up and keeps pushing the rocket higher. Each stage is like a relay runner, handing off the baton to the next, until the rocket is almost in space. As it climbs, gravity and air resistance keep fighting back. The higher the rocket goes, the thinner the air gets, but gravity is always pulling it down. The rocket must go super fast, around 28,000 kilometers per hour, to reach orbit. That's the minimum speed needed to stay circling the Earth without falling back. That's 8 times the speed of a bullet. Just imagine something moving so fast, it could circle the entire planet in about 90 minutes. Now, orbit doesn't mean no gravity. In fact, gravity is still very much there, pulling everything toward Earth. The rocket is actually falling around the Earth, but it's going so fast sideways that it keeps missing the ground. That's why astronauts and satellites seem to float. They're in constant free fall. That's what we call being in orbit. It's a delicate balance between speed and gravity, and it's what keeps our satellites and space stations circling the planet. And what about the astronauts and satellites? How do they ride this fiery journey safely? They sit at the very top, safely packed in the payload section. This is the precious cargo, protected by layers of technology and safety systems. Once the rocket is high enough and fast enough, the last stage separates, and the payload floats freely in space. This is the moment when satellites are deployed, or astronauts begin their mission in orbit. So basically, a rocket is like a stack of fuel tanks, engines, and smart engineering, all working together to beat gravity. Every part is designed for a specific job, and nothing is wasted. It's not just power, it's brains. Teams of scientists and engineers spend years perfecting every detail, running simulations, and making sure everything works perfectly. Next time you see a rocket launch, remember, it's not just fire and noise. It's the result of decades of research, teamwork, and a passion for exploring the unknown. It's a perfect balance of physics, technology, and a little bit of Indian jugaad. Our scientists and engineers are always finding clever ways to solve problems and make space travel more affordable. If you enjoyed this quick journey from Earth to orbit, don't forget to hit like, share with your friends, and subscribe for more amazing science stories. Your support helps us bring more space adventures to you. Until next time, keep reaching for the stars. Who knows, maybe one day you'll be the one riding a rocket into the great unknown.